Here is the 7-minute script. A piece of malware is sitting inside Cisco firewalls right now, watching patches get applied, and not moving. That's the short version. The longer version is that US and UK cybersecurity agencies have issued a joint advisory about a backdoor called Firestarter that has been found persisting on Cisco ASA and FTD devices, even after firmware updates and security patches are applied. If your organization runs Cisco Firepower or secure firewall hardware, this is not a story you read and file away. This is a story you read and then go check your devices. Let's establish what we actually know, what's confirmed, and where the reporting goes vague, because there's a lot of vague in this one. The advisory comes from CISA and the UK's NCSC, which means it cleared a fairly high bar for publication. These agencies don't typically co-publish unless the threat is assessed as serious, persistent, and likely to affect organizations in both countries. The malware is named Firestarter. It targets Cisco Adaptive Security Appliance software and Firepower Threat Defense software, both of which run on Cisco's firewall and network security hardware. The defining characteristic of Firestarter, and the reason this is alarming rather than merely inconvenient, is that it survives the update process. You patch the device. You apply Cisco's security fixes. Firestarter is still there when the device comes back up. That behavior has two plausible explanations, and neither of them is comfortable. The first is a supply chain compromise. That would mean the malware is embedded somewhere in the firmware or the update mechanism itself, so that applying a patch either doesn't touch the infected component or actively reinstalls the malware as part of the update. Supply chain attacks against network hardware are not theoretical. The VPN filter campaign in 2018 hit hundreds of thousands of routers across multiple vendors. More recently, researchers have documented implants in Cisco iOS XE devices that survived reboots by hiding in the device's file system in locations the standard update process doesn't overwrite. The second explanation is a zero-day persistence mechanism. This would mean the attackers found a vulnerability in the ASA or FTD software that allows code to be written to a location that persists across updates, something like a management plane component, a bootloader region, or a dedicated storage partition that Cisco's update process simply doesn't touch. This is arguably the more targeted and more sophisticated scenario because it requires deep knowledge of the device internals. The advisory, based on the reporting available, does not definitively confirm which of these two mechanisms is responsible. That is a significant gap. Unclear from the reporting whether CISA and NCSC have forensic evidence pointing to one over the other, or whether the persistence mechanism has been fully reverse-engineered. What they do confirm is the observed behavior. The malware persists post-patch. The implication is that standard patch and move-on remediation is insufficient. Now, what does Firestarter actually do once it's on a device? This is where the reporting gets frustratingly thin. The name Firestarter suggests it may function as a dropper or loader, meaning its primary job is to establish a foothold and then pull down additional payloads or tools. That's a common architecture for sophisticated implants targeting network infrastructure. The attacker doesn't put everything in the initial implant because that increases detection surface. Instead, the implant is small, quiet, and persistent, and it phones home or waits for a signal to deliver the next stage. If Firestarter follows this pattern, then the real damage, credential harvesting, lateral movement, traffic interception, command and control tunneling, happens through secondary payloads that may vary per target. The advisory apparently does not publish indicators of compromise for those secondary stages, at least not in what's been publicly reported. That's either because they don't have them, or because they're holding them for operational reasons. What we do know is that network layer implants on firewall hardware are particularly dangerous for a few reasons that are worth spelling out for anyone who needs to make the case internally for taking this seriously. First, your firewall sees everything. Traffic that's encrypted end-to-end between clients and servers still has metadata visible at the firewall. Source IPs, destination IPs, timing, volume, session duration. An implant with access to the firewall's data plane can build a detailed map of your network activity even without breaking encryption. If it can intercept pre-encryption or post-decryption traffic on segments where the firewall does SSL inspection, which many enterprise deployments do, then it has access to plain text. Second, firewalls are typically trusted infrastructure. Your SIEM, your EDR, your log aggregation, these tools are often configured to trust or deprioritize alerts from firewall management interfaces. An attacker operating from inside a firewall has a privileged position in your monitoring architecture. They are inside the thing that's supposed to generate the alerts. Third, and this is the operational pain point, if the persistence mechanism survives patches, your normal remediation playbook doesn't work. The standard response to a compromised network device is to push a clean firmware image, change credentials, and verify configuration integrity. If Firestarter survives that process, you may be completing that checklist and walking away thinking the device is clean when it isn't. So what should teams actually do right now? The most important immediate step is to verify whether your Cisco ASA or FTD devices are in scope. Check your asset inventory for any hardware running ASA software or FTD software. Cisco Firepower appliances, Firepower 1000 series, 2100 series, 4100 series, 9300 series, and the Firepower Services modules on ASA hardware are all relevant here. If you're running Cisco's Virtual ASAV or FTDV in cloud or on-prem environments, unclear from the reporting whether those are equally affected, since the persistence mechanism may be hardware-specific. That's a question worth raising with Cisco TAC directly. For devices that are in scope, do not assume that having applied recent patches means you're clean. The advisory's entire point is that patching alone is not sufficient for detection or remediation. You need to look for indicators of compromise at the device level. Cisco has published guidance in the past on forensic examination of ASA and FTD devices, including checking for unexpected files in the device file system, anomalous processes, and unusual outbound connections from management interfaces. Pull that documentation and run through it. If you don't have the internal expertise to do that forensic work on Cisco hardware, this is the moment to engage Cisco TAC or a third-party incident response firm that has done this before. Check your firewall management traffic. Look at what connections your firewall management interfaces are initiating outbound. Firewall management interfaces should not be making connections to arbitrary external IP addresses. If you see outbound connections from management interfaces to IPs that aren't your management infrastructure or Cisco's update servers, that's worth investigating. Review your network segmentation for the management plane. If your firewall management interface is reachable from the internet or from broad internal segments, that's a configuration problem independent of Firestarter, and it increases your exposure to this class of attack. Management interfaces should be on out-of-band networks with strict access control. Engage Cisco directly. Cisco's CERT team is presumably working on this given the joint advisory. Ask them specifically what detection tooling exists for Firestarter, whether they have a verified clean image process that guarantees removal, and what their assessment is of the persistence mechanism. If the answer is vague, push harder. You're a paying customer running their hardware at your network perimeter. One more thing worth noting about the broader context here. This is not the first time Cisco firewall and router software has been the target of sophisticated persistent implants. In late 2023, Cisco disclosed that threat actors had compromised iOS XE devices through CVE 2023-20198, a maximum severity authentication bypass, and installed implants that in some cases survived initial remediation attempts. The pattern of targeting Cisco network infrastructure is established, and the techniques are getting more sophisticated in terms of persistence. If you're a security team that's been treating Cisco device security as a lower priority than endpoint or cloud security, that calculus needs to change. The real situation here is this. A nation-state level actor, attribution is unclear from the reporting, but the sophistication and target profile suggest it, has developed a capability to implant persistent malware in Cisco firewall hardware that survives the standard remediation process. The U.S. and UK governments thought this was serious enough to issue a joint public advisory. Your immediate action is to audit your Cisco ASA and FTD inventory. Run device-level forensics, rather than assuming patch status equals clean status. Lock down management interface access if you haven't already, and get a direct answer from Cisco on what a verified clean state actually looks like for an affected device.